Okay. So feel free to grab food, drinks if you haven't yet. There's water there as well. And let's start. Cool. So hi everyone, this is Binal here. It's our first firmware meetup in Bay Area. So welcome everyone. I'm happy to see a good crowd. And the idea of starting a meetup came like during one of the recent conference I had attended. It's called OSFC, which is Open Source Firmware Conference. And I met a lot of people in the firmware area, and it was so nice to connect. So then couple of us met later in a coffee place, and we thought like, why don't we start a meetup here? Because one of the reason was like I was looking on meetup.com and other places, and there wasn't anything other than like there's one in SF, but like nothing for East Bay or South Bay. So that's where this idea came, and then made it happen. So here you are. And for those who don't know me, I work at Amazon as part of the data center org, and I work on the BIOS and BMC firmware. So BMC stands for Baseboard Management Controller. It's an embedded board on this server, and that's what I do in my full-time job. So today we will be talking about this nice simulation tool that I also learned during OSFC, and it provides a lot of like nice features. So I was playing around it, and I thought like, okay, this is a great way to like simulate your embedded projects and see what's going on. And we will be, so the project we are going to do is IoT based, and it uses MQTT protocol, and I'll be talking more about that later. And we will be creating a weather station. So it will be publishing the temperature and humidity data to an MQTT server, and then we will be able to see those messages. Now you may be wondering like, how do we do an IoT project with a Wi-Fi on a simulator tool? That's where Wokwi comes in picture. So, and this is an open source tool. We will be covering a lot more on that. But just to give an idea of like what we are covering today. And then we'll run through the simulation of this IoT project. We'll see the data live, and followed by networking in the end. And some of you already met, so that's great. So what we need today, if you have your laptop, you can follow along with me. I will be showing what all we'll be doing on Wokwi, and what components you'll need. We'll be designing the circuit with ESP32, and we will be running the program, and then we'll see it live. So all you need is your laptop, and that works. So about Wokwi. Has anybody used Wokwi here or heard about it? It was same for me about 2 months ago. So it's a electronics simulation tool which allows you to develop this projects for microcontroller. I think they support Arduino, ESP32, Raspberry Pi, Pico, this kind of like popular circuit boards, and you don't need a hardware. So it saves a lot of time that you are waiting on your hardware. You can run some simulation during that time. It also has a lot of like support for some of the basic components and some of the popular components like temperature sensor and your actuators and other components, which we'll get to see. So the main reason we are using Wokwi today is to prototype our IoT project, and to make this happen within half an hour of our presentation. This is the best way to achieve that, and it's also a good way to learn like how to debug your projects using a simulation rather than depending on the hardware itself. So this is just what I was listing when I was looking at this tool and what all you can do. And I think like when I'll show you the tool, it will make even more sense. But basically what you can do is like you have like similar to your, like you have your ESP32 on with you the actual hardware, and then you want to add some sensors or you want to connect some things and control through the GPIO, then you would be using a breadboard to start with. So you can do the same thing with Wokwi, and you can drag and drop those components. They also have option which is pretty cool, like they have like smaller mini boards and like big size boards, so depending on your requirement you can add multiple breadboards. Then you can do the real-time simulation, which is what we'll be doing today, which you'd be able to see the sensor values changing in real time. We'll be using the temperature sensor, it's called DHT22. We can also do Wi-Fi simulation, and this is actually the best part that I liked about this particular project is that this tool actually provides a virtual Wi-Fi that we can use to prototype IoT projects and maybe more. So they have some good examples on their website as well, and I'll show you like where to find all this information. And obviously there's a built-in code editor. The languages they support so far have been C, C++, MicroPython, Rust. I think that's about it. Maybe they are adding more, but so far I see that. And you can do a real-time collaboration as well if you're working with somebody. And the best thing is it's open source. You can actually check out their code, add some more support if you want, and it's free to use. You don't need any software. You can use the web version. But it also comes with the VS Code extension. So if you're interested in using it with your IDE, you can do that as well. Today we will be using the web tool. So we'll be building the IoT weather station. For this, we will be using ESP32 and the temperature sensor. The protocol that we use for IoT will be MQTT, which is the messaging protocol. And this is like a widely popular protocol, at least in IoT industry. I've used few others as well, like because I was working on IoT SDKs in my previous job at Microsoft. But this is like particularly more popular due to its like limited bandwidth and perfect ideal for resource constrained devices, especially small embedded devices. So the way it works is if you've never used IoT like this kind of the protocols, the way it works on MQTT is that there is a publish and subscribe model. And what that means is you'll have a publisher which is sending these messages to your server, and then on the subscriber side it will be listening to a particular topic. And topic is basically, you can think of it as kind of like a formatted string. Let's say if you're monitoring temperature for your entire home, then it can be something like /home/kitchen/temperature, or it can be /home/bedroom/temperature. So that's what the topic means here. You can think that that's just an analogy. And the good thing is, like, all you need to know is like this: the subscriber needs to know is the topic that they need to subscribe to, so they can listen for the messages that's coming in. However, the important entity here is the broker. So that is the MQTT broker that does the orchestration for this entire process. So it receives the messages from publisher, and then it routes them to the the listeners that are listening for this. And for simplicity, we are going to use this Hive MQ MQTT broker and also the subscriber for this project. It's a free to use. So I would ask you to go to this, you can either scan the code or you can go to my GitHub where I have some examples, and I'll show you what to do from there. Oh yeah, if you need the Wi-Fi, it's here. Yeah, I should have mentioned that. Thanks for that. Okay, so I hope you all got that. So we are going to open this sample project. This is one of the project that's already there on Wokwi. Let me zoom in a little bit. Okay, which is I think let's make this way. So as you can see, this is the simulation window. I'll give a little bit overview of like this tool and what all is there. And then you have, this is the temperature sensor. The cool thing is like all these components, like if you don't know what pin is for what and how to connect, you can click on this icon. It takes you to the reference guide and it tells you like what all input output is there and what are the default values, how do you control temperature, and in fact they have some good examples as well. So going back to this, so all this is doing is like it's connecting the temperature sensor to ESP32, and we are going to use some of the libraries from the libraries that Wokwi tool provides. This is called, this is for the DHT22 temperature sensor and also for MQTT. So the MQTT one that I was talking about initially about the Wi-Fi simulation, so that's what we are going to use. And these are, like, you may be wondering, okay, those are the inbuilt libraries, but what about things that's like libraries or API that's, for example, supported by FreeRTOS that you want to use on ESP32? So you can do that as well. And there is, I think, I was looking through their community projects and I found one where they were using the FreeRTOS with a C code. So you can do that as well in Wokwi supports that. So just going to show, before I run the simulation, I'm going to show like what we are doing here. So we have the MQTT related configuration. This is the broker that we are going to use. It's from HiveMQ. And the topic that I was talking about is this Wokwi weather. You can call it whatever. You can call it your name and anything. And this is our sensor. So we are just configuring which pin we are looking at for DHT22. Then we are connecting to this Wi-Fi network. And once it's connected, it's pretty simple program where we are measuring the weather condition. If anything changes, then we publish it to the MQTT topic. If nothing changes, we are doing nothing. We are just like making sure like if there is any update, we publish it. So now you may be wondering like how would the temperature and humidity change? So we'll run through the simulation and I'll show you that. Before going to that, there are a few tabs on the top. So this is your program obviously, which is in MicroPython. We have this JSON file which shows the diagram, and what that means is like if I add a new component here, for example, let's say I added this LED, and this will show up here. I don't know where it went. Oh yeah, here. The Wokwi RGB LED, and these are the basically the locations, right? So if I move it around, those values will change, and you can configure certain things here. So it's kind of like if you're making some changes to this, some of the samples, and you're trying to add more components and those things, it would be good to save this diagram.json file so you have that handy for later. And this is the library manager that I was talking about. If you want to use some third-party library, then you would be adding it here. So now let's go through the simulation. And before that, we should be doing this. So let's open this link. And then we are going to add a new topic. So here I'm adding a new topic. This topic name needs to match to what we are calling it here, right?
What do you click on to add the topic?
You click on the connect first,
Okay.
and then once you're connected, then click on the subscription. Under subscription, there is this add new topic subscription, and then you wanna change this name to Wokwi weather. I think that's what we called it. This thing.
How do I not conflict with you? It just keeps us all straight somehow.
Yeah, that's a good point. You can, let's call it something else,
I'll
like
call
what-
mine Corbett.
Okay. So now we will run through the simulation and we'll see the data. So you'll see some output here that it's connecting to the Wi-Fi. And this is the default temperature as we were looking at the guide, the reference before, right? If you click on this, you can change this temperature here. So let's say we made it 62% humidity. And
Which thing did you click on?
so if you click on this temperature
Oh,
sensor,
okay.
I think I
Oh.
changed something which it's not happy about.
61C.
Yes.
Oh my gosh.
I change, oh, maybe this. I'm going to reload. Oh, this thing, it's not happy about that. Okay.
That is really slick.
Yeah, it's pretty cool.
I'll make it be like East Coast.
Could you see the updates on
Yeah.
your topic?
I
Okay.
made it 99% humidity and 46C.
Okay.
'Cause that's the East Coast.
Yeah, so now you'll see this data coming in through.
Wow.
So that's kind of like a simple weather station, IoT weather station. Now we are going to do something. Let's try. So Ron is doing. You're also trying the program.
I need the URL.
Oh, okay. Wait. Let me. 1 second.
Oh, mine crashed.
So once you fix this, you just burn it into the ROM or flash.
Yeah, it should be ready, but we are using some of the Wokwi libraries. So if that needs to be replaced with your temperature sensor library. And if we are using free RTOS, then we can use just that same program here and then run through the simulation. Yeah.
Sure.
Did you get it? Okay. Edward, are you able to get that? Okay.
Oh wait, do I need to change something to not conflict or?
Just change the topic name to whatever you want to call it.
Okay.
And then and then run the simulation. You also need to connect to that, basically create the subscription, connect to this topic and create a new topic. That's on HiveMQ, so that URL should be there in the comment section on the top of the program.
Yeah, I see it.
You see it, okay. All right. So I'll probably wait for a couple of minutes since everyone is trying, and then I'll show you what we can do next.
I actually don't know how to take a screenshot with this Pop OS yet, so.
Oh, okay.
This is really pathetic, but this is what I'm gonna do. This is fun.
Yeah.
Curious, where does it actually run the code? Does it run it in JavaScript, like in your web browser, or on like the cloud, or?
This code,
Yeah.
you mean like for the Wokwi, right?
Yes, where is this stuff all running?
Yeah.
Yeah, it's kind of interesting. Like, it looks like Python code, but
Yeah, this is Python code, but obviously it's converting it to it's local, I think.
WASM or something maybe?
really interesting.
And then the broker and subscriber both are running on this HiveMQ. So that's completely, this is just doing the publishing stuff. And obviously the Wi-Fi simulation.
Really, I see it.
You see it?
Yeah.
Okay, cool. All
Is that
right.
like talking to EDK too?
And today's word is incorrigible.
Edward, do you need help or you're good?
I don't think
Okay.
I don't think you can be safe. I don't think you can be safe. We'll see.
Oh, wait till you see what I brought today.
Oh dear. Oh god. Okay. Uh-oh.
Wait, what?
It looks good. This is really slick.
Yeah. I can show the next thing that we are gonna do and you can start with that. So
I was wondering
let's
about this. Okay.
yeah. So I was thinking, instead of us triggering based on the temperature values, let's add a push button and an LED. When you press a push button, it will publish your temperature and humidity data to cloud. And it will also turn on the LED to let you know that it has published, and instead of like looking at the temperature changes. So that's what we are gonna do. You would need a push button and this LED and obviously the pull-up register. The way you will add it is, so you need to stop the simulation first. And then you can click on this plus button in the simulation window. Click on LED. And if you're confused about which one is anode, cathode, if you like move your cursor around, it's gonna say, like, you can also change the color of this LED to whatever you need. And then the other thing you'll add is the push button, so which is this guy. And if you need, you can just grab my diagram.json file, which is in this repo, and then just copy it over, and it will bring the entire circuit board with all the connections. But if not, and you want to try it on your own, I'm gonna just zoom it here.
Good.
So like this bottom one is basically connected to ground here.
Which pin? Oh, ground.
There's a ground right
Oh, I
above
see it.
13, pin 13. And then I'm gonna configure this pin 14 as the one of the input for this basically LED. And for push button, we are using pin 26. You can use any pin as far as it's like, yeah, it supports your GPIO functionality.
You add a wire component. Do you?
Oh, so
double-click?
you basically, oh yeah, I should show that. So it's pretty easy. Where did it go? Okay. So if you click on this,
Yeah.
and then
Oh,
wherever
I
you
see
want to
it.
connect,
Yeah.
it's just gonna connect the thing.
That is sweet. Okay. And what? Okay.
Yeah, oh, there, yeah, here.
There we are. And so you did.
It's pin 26
that,
for push button.
that, and then that's the pin 14. Okay. And then the button is ground on one side and 26. Okay.
Yeah, button is grounded to the same ground pin. It just looks like overlapping, but
Wait, which pin is the LED on? Because that.
LED is 14.
Oh.
Yeah, and you need to add a pull-up register. I just put 1K.
Oh, that's a hoot.
What is it?
This is really cool.
Yeah, yeah.
It's got some funny rules for how it lays the wires out, but whatever.
Actually, for your question, I just thought like, so Wokway's GitHub, we can look at that after this
You're looking
and then
for-
figure out. Yeah, it's open source,
it's
so
open source. Oh, that's really impressive.
yeah, and it's pretty active community as well.
I was kind of curious if we could add support for Go.
Here,
That
Addition of
I'm
language.
actually gonna write to the Tiny Go guys tomorrow and say, hey,
I was looking for Go before this session because I knew Ron is gonna ask
you
for
knew it.
Go.
You knew what I was gonna ask for. Yeah.
It'd be really cool if you could run Tiny Go.
So are we there?
Looking through the buttons.
Yeah. Okay. So, and then I basically added just a configuration for the LED and the push button, like which pin we are gonna
To
use.
the diagram.json.
Yeah, you
Yeah.
can copy the diagram.json from this if you haven't made the connection yet. So which is this one.
Oh, no, I did make the connection.
You did, right?
Yeah.
Then if you want for the code is in this MQTT sample modified
Okay.
.python, and there are a few things that's changing which I kind of listed here. One is like you need to configure the LED and button, like which pin you're using, and set the direction and pull up. So you can copy it. It's line number 37 and 38 in this script. And I think the other thing that changes is since we are now, instead of looking at the previous weather, we want to update the basically publish these values when the button is pressed. So which is this part, line number 63, and we are changing the value of LED to 1, which is we are turning it on, and otherwise the value stays 0. I also changed the interval for the sleep function, and the reason for that is because otherwise, like, it was waiting for 1 second, so you have to press the button quite longer for it to actually update it. And if you want, you can just copy this code and just put it there. I think there are a few imports I might have changed. Let me see. Okay, second. Yeah, no, it should be fine. So here it is. This one. Sky. Hey. Yes.
Hi.
Finish work, sorry.
Now you have to pay off your registration then.
Oh, that's.
I'm Ron.
Alex.
Good to meet you, Alex.
Feel free to take food or drinks if you want.
I love it.
So let's run the simulation. Is everyone ready? Connecting to the Wi-Fi. Or change the topic name as well if you haven't.
This would have been a very popular talk.
Yeah. I mean, first time I learned this in OSFC, one of the presentation, I was like, how come we have never used this before? So, would be a nice one.
Yeah. A lot of possibilities.
Sure, why it's taking longer. More meetups happening at this time.
Too many meetups. Yeah.
since we're doing IoT stuff, this is an Orange Pi 5 plus. Yeah.
You should talk about that next time
Yep.
if you're interested. Do some hands-on on that.
We could. I do still have the Orange Pi 5, but I upgraded to the plus model of it.
It's like a Raspberry Pi.
It's one of the competitors. This instead has a Rockchip 3588. And some of the notable features, it has 2 slots for PCI Express.
That's impressive.
It has 2 HDMI outs, HDMI in, has a bunch of like MIPI, DSI and CSI connectors. And yeah, it has like RTC, which you can connect a battery up to, which I did. And yeah, it's about as powerful as like the 7th gen i5. That's ARM.
How much is it?
It's like $112. Then that's just for the board.
Yeah.
Put a bunch of stuff around it, like a Wi-Fi card and a SSD and case.
You got the enclosure, or
Yeah. I
okay?
was contemplating 3D printing one, but I just bought one.
That's really fun.
Yeah. Were you able to connect?
Yeah. No,
Oh.
I was running. I punted and just took your Python code, but
That's
I
fine.
did the schematic myself, and much to my amazement, it worked.
Oh,
So-
did it work with the push button?
Yeah.
Oh, okay, perfect.
Yeah.
Now we are good.
Yeah, that's what I was taking
So,
the video of.
so see the LED is on,
Yeah.
and now let's see if the message came through, which it did, 1832. So this is the temperature. Let's actually change it.
But we could really have literally. So if we all said Wokwi weather, I guess we could have multiple weather stations, quote unquote, right?
And
I
so
could-
now
I could-
publish it again.
Sort of
Ah, it crashed.
DDoS your weather station.
I wonder if someone is doing that, because I should change the topic then.
No, but this is good. This is there we go. Occasionally I get a connection reset. And I do it.
Yeah, I got that too.
But I
1832.
think for free I'm okay. So if this even came up.
Yeah, it's not liking this. Something to debug later, I guess. But you get the point. So, that was the demo. And I want to leave you with a few resources for Wokwi. So, we have this is the repository that I was talking about, and we can look at that later. Where, like, I basically highlighted some of the directories, subdirectories which are important, where Wokwi being the main repo, and then elements for the electronics and IoT parts. So that's where you were saying, like, this temperature sensor and other things. Then there is a library index, which is managing the index for this, like the library through which we are adding third-party libraries and other things for our projects. There is a CLI, which is to help you with running this simulation. And then there is ESP32 test binaries, which is for the ESP32 boards. Now, there are other boards which are, for example, if you actually go to, if you go here, then these are the 4 boards supported. So if you click on Arduino, then it will show you featured projects basically through the community. So like you can play around this different things. Yeah, pretty cool. And modify or like add more things.
32 servos dancing looks very
Yeah.
interesting.
It looks interesting. Yeah, and then there's STM32 Pi Pico as well. You'll see there is a community where you'd see people actually contributing their code, and there is a lot of like examples on C code using FreeRTOS, other libraries, all those things. So a lot to